Good morning, everyone. Welcome to the third plenary lecture in APS 105. It's my pleasure today to introduce my colleague, Professor Michael Stum. For some of you, he is your instructor in APS 105. Let me give you a quick version of the background, of his background. He is actually a Swiss national, right? Were you born in Switzerland? Yeah, but he spent a fair bit of time growing up in the United States, I understand. His undergraduate and graduate degrees were in Switzerland, and he did a postdoc at Stanford University, after which we captured him here at the University of Toronto, and he's been a professor working on software engineering and operating systems ever since then. But also, during that time, he was the co-founder and founder of two separate companies, one called Soma Networks, which delivered high-speed wireless cellular technology long before there was high-speed cellular technology, I think is correct. Second company was called Oanda, which still exists and is a foreign currency trading company that on any given day, I remember you told me several years ago, something like $10 billion flows through that company. They don't actually keep all that money, they keep a piece of it. So he was the CEO of that company and developed a lot of its very sophisticated software. So please join me in welcoming Professor Michael Stum.
Oh, yes. We're good. Can you hear me? Okay, very good. Let me first do a couple of disclaimers. Number one, the title of the talk is just link bait. I have very little to say about Facebook software. Especially since this is videotaping, goes up on YouTube, that means I can say almost nothing. The second thing you should be aware of, though, is that I am paid by Facebook. I do get money from them. They also fund some of my research, etc. So anything I say about Facebook is biased. Just take that into account with what you hear today. Okay. Thirdly is I absolutely hate the Facebook product. I think it sucks. I never use it. I have an account because I have to, but I've never posted anything to it, and I guess I'm just not a social person. It doesn't interest me. However, the company is great, the management is great, I'm a big fan. Otherwise, I just don't like the product, okay? And then the fourth disclaimer maybe is a lot of what I say is a little bit controversial, so most people who do software will not agree with me. Most people who study software engineering will not agree with the views that I say. I'm a very opinionated person. Nevertheless, I'm convinced that I'm right and they're all wrong. And they're all stuck in the past, their heads are in the sand, and they're just too scared of the future that's going to hit them. And we will see that over time, what I will present today or describe today will actually take place because it will be the future. Okay, so let's get started with the actual talk. I don't know how many of you know of a company called Etsy. It's a Brooklyn company, Brooklyn, New York. They sell handmade stuff sort of similar to eBay. So it's an eBay for handmade stuff. It's actually pretty popular. They do a lot of stuff, and it's a fantastic company. And here you see some of the working environments down below. It's very nice to work there. Okay, so when you go there as a developer, let's say they hire you. On your very first day, you come to work at 9 o'clock in the morning, and for the first 2 hours, you have to sit at a desk and fill out forms. What's your bank account so they can send you the payroll? What are the insurance forms? You have to sign non-disclosure agreements, IP agreements, all the boring administrative stuff you have to do at a company. And then your boss comes and picks you up, shows you where your new desk is with a computer terminal, and then he pulls you into his office and says, look, we have a bug here. Let me show it to you. Can you go find it, please? Then you go back and you start looking and try to replace it, etc. And after about 3 hours of work, you find the bug and you're all proud. You go back into the manager's office and say, I found the bug. And he just looks at you and says, well, why are you bothering me? Have you fixed it? And you say, no. Then he says, well, go fix it. And so you go there and you fix it. And of course, the manager was smart. He picked a relatively simple bug. But anyway, an hour later, you sort of put in the code to fix it because it's not too difficult code. You go back to the manager and says, well, I think I fixed it. And he says, well, why are you bothering me? Go deploy it. Now, deploying means you take that software changes that you made, you put it out into the main code base that everybody's running on, all the clients are running, and you put it out there, and people will start using your code. And that's a little bit harrowing when you're doing that for the first time, but you go and ask people around you, is this okay, and what do I do here? And then he said, well, all you have to do is open this tool, point it to your code, push a button, and it's out there, and people will start using your code. The general public will start using your code. You do that. So what it means is from an idea as to how to fix a bug to actually deploying it so people start using that new code that you just wrote happens on the same day, your first day. It's a very frightening experience. You might wet your pants, but it's exhilarating because you write stuff and people start using it almost every day. And that is a modern way of doing software, and we'll find more and more companies are operating in that mode, and it's completely different than the other mode. It's a very revolutionary mode. So just, I have to admit, again, disclaimer, one of my kids works at Etsy. In fact, he's one of these people here you see in the pictures, and so again, what I say is a little bit biased, but I'm a big fan. But what they do was at the time when they started it in 2011, very revolutionary when they picked up that mode, and it changed a lot of things. They were a very advanced company in doing so. And what it pits sort of against each other are two different ways of developing software. On the one hand, you have what is traditionally called the waterfall model, which is the traditional way. This is what they teach you at universities. It's a lot of planning, a lot of documentation, and the basic idea is sound, and it was sort of introduced in the early 70s, where we had a lot of software failures. They said, well, gee, you should treat software like an engineering discipline. And so you got to plan, like building a bridge. You don't just willy-nilly build a bridge. Somebody's got to plan it out. Somebody's got to do the math behind it. You've got all these people thinking about it, et cetera. You put it together, you document it carefully, and then you got crews going in and building this bridge, and that's exactly how software should be built. Okay, that's the basic idea. And you have specialized teams who do certain things, and I'll go through what these different teams are in a second, et cetera. And it became popular in part because the US government, which is the largest purchaser of software in the world, simply says, well, if you want to do software and work for the government and provide it to the government, you must use the waterfall model. That's their dictated, okay? And this is quite different from what modern companies do, like Etsy and Facebook. They use something that's called Agile development, where software, instead of creating large pieces of software, we have months of planning to put it all together and get it right. You work very iteratively in very small increments, and you release it out to the public relatively quickly. Whenever somebody sees something that they don't like, you adapt to it and you make those changes very, very quickly. You basically don't document things. You just write the code. Your code is the documentation. So it's counter to what everybody teaches you all the time. And in fact, it's counter to the talk you heard last week. Forget everything you heard last week. It's all wrong. They're doing it the old-fashioned way, right? But the key thing is you have a lot of responsibility. The individual is responsible, and so it's a little bit tougher if you're a developer because now the responsibility rests on you, but you are much more agile, okay? So this is the old world. This is the new world. There's lots of people who claim that the old world has lots of merit, and this is how you actually have to do software and should do software if you want to do it right. And strangely, it's new companies are doing it differently. They're doing the agile way, and it seems to work. But the naysayers that believe in the waterfall model still claim, that'll never work. And so we'll have to see, and history will tell. So I'm going to go and talk a little bit about the waterfall model in more detail. And it'll give you the primary reason for going into this detail is to give you a little bit of an idea as to what type of software professions are there and exist in companies. If you go work for IBM or one of the banks or one of the telco companies here, they all use the waterfall model. They're antiquated. I claim they will all go out of existence once agile companies come and beat them pants off. Okay, so the waterfall model is called waterfall because you've got various silos within the company with different people, different groups of people with different specialities, and they work on doing something, and then they pass their result or what they produce down to the next level. They take that, they work on it, they produce something else, they pass it down to the next level. So it's like a waterfall that goes down, okay? So at the very top, you have something called business requirements. So these are the people at a company that try to determine what type of product what should we work on? What type of product do we create? They do a market analysis to see what is the competition doing, what type of product would we do that would make us potentially successful. They think of the corporate strategic goals, like how fast do you want to grow, what type of company do we want to be, et cetera, and they figure that out. These are usually MBAs, business people who put that together and make those type of decisions together with management, right? Then they come and say, well, gee, we would like this product X. Then they give that to a product manager, right? Now the product manager, a lot of the times, is a former developer that wasn't necessarily very good at coding, but smart, understands things, sees the big picture, and they go in and they define the product in detail. What type of buttons do I have? Round buttons? Do I have square buttons? Are they blue? Are they red? What are exactly the features of that product that I want to have in there, et cetera, et cetera. Often product managers will claim they are experts or they consult experts. Sometimes they go out and do what are focus groups. You guys know what a focus group is? Right? You go you get 20 people together and just ask them questions to try to find out what does the public want. And then based on that, you define the product, and the end result is the product specification. Okay? Now, this is sort of the old way of doing it. The modern way thinking is that, well, unless your name is Steve Jobs or Elon Musk, you're not going to be very good at defining a product. Most people are not. It's very difficult for you to know. What do people want? That's a very challenging problem. And if you go ask the people, you'll go completely wrong, because every time you ask somebody, would you like this feature? They will always say, yes, I want this. Okay? And a classical example of this is MP3 players. So MP3 players, Sony, a modern company at the time, was the leader in MP3 players, and they dominated the market. And then two things happened. On the one hand, Steve Jobs came up with an idea for an MP3 player, the iPod, really, really simple, with a very simple user interface. And Sony did all these focus groups and asked people, do you want this feature and this feature? And they started adding on one feature after the other, one feature after the other. And their MP3 players started becoming more complex and more complex to use. You had lots of features, and you could define everything yourself. You had total control. Apple, you had no control. Steve Jobs had control. He decided what you get to use, and you could basically turn the volume up or down, and you can pick the song, and that was it. And guess who won? Apple won, and the other Sony's MP3 players have become irrelevant. Sort of, they bit the dust. Anyway, so creating products, defining products is a very complex thing, and the modern way to do that is to try to get something out relatively quickly and have actual people use them and see how things work. So, for example, Google, when they have a button and they know they want this button to be blue, they will go through 40 shades of blue and give some users one shade, other users a different shade, and they will measure where do they have more success. And if one shade of blue beats all the others, then they switch to that shade of blue, and then they start testing other things. And all aspects of the product get defined effectively by testing on real people when it's out in production and people are using it. It's sort of the modern way of doing it. You made a reference to that last week with A/B testing. It's also called multivariate testing to figure these things out. Anyway, after the specification is written, they're given to architects. Now, architects are former software developers who were really good developers. They get promoted. And what they do then is, instead of writing code, which is a little bit strange and backwards, they're really good at writing code. So you tell them, don't write code anymore, become an architect. And what they do is they take the big problem and they carve it up and partition the problem into smaller chunks, different modules, different classes, different functions, how these things interact with each other, and they define them, and then they pass them down to developers. Right? So the actual implementation is something called a developer, sometimes a software engineer, et cetera, et cetera. They do the actual coding. But you've got lots of developers, because software is complex. You have lots of people working on this stuff. And so usually you have a group of about roughly 5 to 10 developers. There's a team lead that manages them, keeps on going. And then you have something called a project manager. A project manager is, again, a failed developer, one who didn't perform very good, but is very good in communication. They run around between the different groups to make sure they're all aligned, all the communication is working. If a project, one part of the task is dependent on another task, they make sure the first one gets done first, etc. They walk around with gigantic spreadsheets and Gantt charts and things like that. That's what project managers do. Anyway, in the end, you take the code, and these people, the developers, generate the code. When they're done, they throw it over the fence to a testing team. Now, the testing team is, again, failed developers. Developers you can't use, you put into the testing team, because what they do is not critical in some sense. It doesn't really matter. And all they do is write software to test the software that the developers wrote. Okay? And it's a completely different thing. So they do unit testing and module testing. And here I split it up. There's something more complicated called integration testing, where you take the hundreds of modules that you have in a big complex system, put them all together, and you do whole system testing, or what's called end-to-end testing, et cetera. And when that is all done, and everything you think it works, you hand it over to deployment. And both integration and deployment, those are done by what are generally called operational engineers. Those are software guys or gals who are very, very smart, very good. They understand large systems. They understand operating systems. They understand how everything sort of ties together. And they put the stuff out and deploy it. And the public starts to use the software. And while the public is using, they're constantly monitoring the software that's out in production to see if there's errors or issues or things like that, right? So, and then you maintenance, if small bugs come up, then the maintenance crew may sort of fix it up. The bottom line is it takes often months from idea all the way down to where you can deploy. If you do it this way, you can't do this in minor increments of 2 lines of code, go through this process. So there's a tendency to have very large chunks of software that get released only once a year, only once every half year, as opposed to every day, okay? And so this is the old-fashioned way of doing the waterfall model. And in my view, it's been a complete failure, and it's sort of clear why it is a failure. It has silos where there's very poor communication between the different groups. And just imagine if you're a developer, you're writing code, well, you can be a little bit sloppy. You know there's a testing team that's going to test your software later on. So you don't really care if your software works 100%. Sort of works, you're just fine. We'll pass it on to the testing team. The testing team, no real developer who's good wants to work for a testing team. Test other people's code? That's like cleaning up their mess. Only failed engineers want to work for a testing team. So my advice to you is if you ever go get a job offer and they want to put you into the testing team, end the interview right away and run as fast as you can out the doors and not talk to that company again, because once you're stuck in testing, you will never come out. The companies will promise you can then go up to become a developer and then an architect if you're really good. It never happens, right? Testers are always failed software developers, right? And so when something goes wrong, guess what happens? Well, the developers points to the testing people and say, my God, you didn't do a job. Your job was to test this and find it before it gets released. And the testing people point to the developer and say, my God, you wrote crappy software that doesn't work. And there's a lot of finger pointing and everybody gets upset. It's just a model that doesn't work very well. And if you look in practice, if you look at productivity, you'd be shocked as to how low the productivity is in the software industry. And I'm talking real software like IBM, et cetera, et cetera. And this has been studied and well measured from 1970 all the way to almost 2000. The average software engineer produces roughly 10 lines of code a day, right? So just imagine when you do a lab, which is about 10 lines right now, how long does it take you? Half an hour. Well, okay, because you're beginners, maybe a couple hours, right? A professional software engineer produces on average 10 lines of code. Then starting 2000, it starts to increase a little bit and goes to 20 lines of code, primarily because the web starts to come out and it's easier to write code for the web. It's less critical, it's less important, and HTML lines are easier to write. So in general, productivity has been very, very low, and it's been a gigantic problem for software engineers. How do you fix that? What is the problem? Why can't you would expect a good software engineer to generate 100 lines of code a day somehow, but it just doesn't seem to happen not with the waterfall model. What's worse, the software sucks, okay? It's full of errors, it's full of bugs, it crashes. Most of the banking software that you use is insecure, et cetera. It has problem after problem after problem. In fact, over 50% of the software that people write never sees the day of light, never gets used by anybody, because the software is either useless, because some project manager said, let's produce this and nobody wants it, or because it's so full of bugs, nobody can do it. And this thing can cost a lot of money. The most classical example, perhaps, is IBM, who understands software very, very well. In the 1970s, or was it 60s? Anyway, early 70s, 60s, somewhere around there, they created a brand new computer architecture called the 360 architecture that was truly revolutionary. Watson bet the entire company on this new architecture. It was revolutionary, and in fact, it held for over 30 years, which is rare that an architecture holds this long. And when they created this hardware, they had to write an operating system for it. So they thought it would take a team of about 50 people about 3 to 6 months to write an operating system for it. So they sent them to it. And it turns out the software never worked. They couldn't get it to work, so they started adding people to it. In the end, they had 2,000 people working on it. And that, of course, makes it much worse, because everybody's talking to each other in different opinions, et cetera. It took them over 2 years to create the operating system. During that time, they had warehouse after warehouse of this expensive mainframe equipment that people wanted, that was truly revolutionary, and it was rusting away because the software didn't work, right? And they found for every bug that they fixed, they introduced 2 new ones. So it got worse and worse over time, right? And it's typical of the software industry. If you go look, the quality is abysmal, okay, if you really look under the covers, okay? So that is all the waterfall model. Now, on to the Agile model, which is a little bit different. And the Agile sort of went through various phases, and I'll go through the phases for you if you're interested. So initially, it started in 2001. A bunch of smart software engineers got together and says, this waterfall model just doesn't work. We got to do something different. And they came up with a manifesto on what has to change. And they knew how to do it, and they were absolutely bang on. And they said, forget all these hierarchies, forget these silos, forget the documentation and the big planning. We got to do things in small increments and get it going, okay? So for Agile development is basically, the idea is, don't have top-down structures, but let people get together that want to work together and have them be self-organizing and self-controlled, and empower the developers and let them go and talk to the people that they need to do. Try to get your software to the end user in some form, even in the form of a prototype, as quickly as possible, because documentation is useless. Nobody reads it anyway. But get the software, at least some working software, to end users to try it out, because you can see then how they react to it, what needs to be changed, and you can iterate on these things continuously. So it's really, it argues for an evolutionary development, continuous improvement of the software. You iterate on it. You bring it out, even though it's not perfect. You see how people use it. You work on it. You try to iterate it some more. And so the bottom line is you want to be rapid and flexible, responsible to change. So these people came out. These are very smart people that had a good inkling because they were successful writing software, and they noticed that they did not use the waterfall model while they were developing software. Okay, so after a while, some people started to do that. Continuous integration takes that a step further, and the basic idea is the same, except you have a requirement that whatever code you as a developer write, you have to submit it. You have to finish it off so it's functional. The bugs are out, and you have to submit it up into a master group of software, and that is automatically built together, sort of integrated together to see if it works. Can I integrate them? Can I link everything together? And it's automatically tested in the evening to see, do you have bugs, right? Now you may have a bug, but then you'll get a nice email saying the code you submitted last week has this bug and this bug and this bug, and in the morning you can work on it. So it forces a certain discipline on you that you, at the end of every day, you put out your software and let people look at it, see does it work, Does it have problems, et cetera, okay? So then one minor step further is continuous delivery. The idea there is to not just have software and maybe has a bug or not, but actually make sure there are no bugs every evening. Whatever you write, whatever code you write, even if it's only 10 lines, those 10 lines, you have to be able to put it up into a system that you believe will work. And so you have daily end-to-end user acceptance testing. That means somebody at the client or some end users start looking at that software, start playing with it to get an impression, does it work or does it really play, right? And so the idea is you want deployment-ready code at the end of every day for any code that you write. So you never write increments of more than a day of code before you put it into production and let people use it, okay? And this is pretty radical. Okay, so at one of my companies, we had about 100 engineers. We were doing this up to continuous delivery, but it's not quite the same, the same as actually putting it out to deployment and actually having people use it. Say you got to be ready, because it's easy to say, yeah, it's ready, but having to have actual end users use it is a different matter. You got to push it out. So we thought, well, let's see if we can do what's called continuous deployment and bring the software out to the end user at the end of every day. So as soon as you do something, you say, I'm done, I'm confident this works, and I simply push a button and it goes out to the end users like Etsy does. That is called continuous deployment. Now for Etsy is primarily a web page, and so that's relatively easy. In our case, we're doing billions and billions of dollars of transactions in a very complex distributed system in the back end, so we were going to do it for that. And we started working on it. And for that, you had to create a whole bunch of tools to be able to manage that, because you've got hundreds of pieces of software that are being developed in the small company in parallel. You've got to be able to track it all, see where it's going, and let people push and get it out to the public. You have to have tools so that in case it doesn't always work well, sometimes you push it out and you notice, oh, damn, it doesn't work. You've got to be able to push an undo button that takes that software out and reinstalls the previous version, put it back in. You've got to put all those things together. Anyway, so that is all continuous deployment. In all this, there is no testing team. Testing teams are a bad idea, and you should never work for a company that has a testing team. That would be my recommendation. It's an interesting artifact that almost modern developers want to work in this type of environment, in an agile environment, because you do your stuff, you're much more productive, you push it out relatively quickly, you get people to use it. It's a nice environment to work as a developer. And so the big companies, all the telcos, the banks, IBM and HP and other companies, they're finding it difficult to hire people, the good developers. So everybody now claims they're agile, right? And Agile has different properties. One of the things you tend to do in an Agile, you don't have to, but one of the things you do is you get all the people together for 5 minutes at the beginning of every day around a project manager on sticky notes on the board to decide who's going to work on what, or what problems have to be solved, or what's getting in the way, et cetera. Those things are called Scrum meetings. So almost every company introduces a Scrum meeting and then says, we do Agile, right? And so when you go for an interview and you ask, oh, do you do Agile? Almost every company will say yes, okay? The next follow-up question that people don't ask that you should ask is, can I write code today and have end users use the code by tomorrow? And if they say you're crazy, they don't do Agile, okay? It takes a lot of work, and to put together continuous deployment takes a lot of tools. It took us 2 years before we had that ability. And on average, every developer at our company put out software to the public where people would use it into production every 2 days, okay? So relatively frequently. So we had about 100 developer, we do about between 50 and 100 releases every single week. Hundreds, about 200 releases every week for about 100 developers, okay? Now, when we did this, I swear we invented it. We thought we invented it because we were the only ones. And then I went to a conference a couple months later, and I meet up with the CTO, coincidentally, CTO of Facebook. And we talk about what we're doing. So I tell him about how excited we are. We're doing continuous deployment. And he says, oh, that's interesting. We just worked 2 years to do the same thing. And then we start comparing notes, and we found out, gee, we wrote the same tools. And it took them also about 2 years to get online. And we found that our processes were almost identical. We didn't know about each other. They certainly had never heard of us, and we didn't know they were doing this. We started comparing this and we thought, this is interesting. We should write a paper about this. It's fascinating how two different teams come to the same conclusions and design things exactly the same way to do it the same. It took 5 years, but we finally got the paper out earlier this year that describes it. So it turns out that not just we do it, but Facebook also does it, right? And then we start looking around, and then we find out, oh man, there's a whole bunch of companies that are doing it. So Etsy, as I explained at the very beginning, does it. I don't know who's heard of IMVU? Excellent. They were actually the very first. As far as anybody can tell, they were the very first. Etsy copied it from them. And then you have the great, you guys know about Flickr? Okay, the great Canadian company Flickr that sold out to Yahoo, okay, also did it from very early on, right? So in 2011, Etsy did 11,000 deployments of software, 11,000 times. Code went out to production where end users would use it. It's absolutely fascinating. Facebook, on average, every developer puts out software every day, on average, measured over a long period of time. And their productivity is about 80 lines of code. So instead of 10 to 20 lines, that's industry standard, at Facebook, productivity is about 4 times to 8 times higher. They do about 80 lines of code a day. And this is measured over long periods of time. Actually, a company that's actually pushed it even further than, where are they? Netflix, where's Netflix? Oh man, it disappeared. Okay, Netflix is actually ahead. There, the average developer puts out 2 software releases a day. So after half a day, they push it out. They're the most advanced company for agile development, agile deployment, as far as I can tell. And you get all these companies that do this now, which makes it sort of very interesting. Tesla, it's a car. And they can create software and push it down to your car within the same day if they want to. Now, they tend not to do that overall, so when they create new software, it could be a little bit dangerous, especially for driving a car. So what they do is they pick maybe 20 random people in Stockholm, download new software for these 20 people, and let them try it out, and they can see how it works. And when that works, they start drawing it out to more and more companies. At Facebook, I can't go into too much detail, but when they release software, it's not like all of a sudden everybody in the world gets that product release and those changes right away. They will typically start in one place where not a lot of people use it. Let's, for example, I'm making this up, but let's say it's the southern tip of Chile, right? And if something fails there, oh, they'll say, oh, poor communications, it's the communication problem. They won't blame Facebook, and they can immediately fix the problem. If it works, then they got levers where they can start letting that software change move up through Facebook, through the rest of South America, onto North America, to Europe, and they can, on a lever, have 0 people use it all the way to 100% of the people use it. And whenever they see a problem, they just pull the lever back. And they can do that on every piece of software that gets deployed, okay? Another interesting thing is, I don't know if you've ever had, some of you use Facebook? Okay, do you use the mobile version? Has anybody ever had a crash? Very good. Okay, so what you don't know is, to give you an indication of the type of tools Facebook has, when your Facebook app crashes, what do? You start it back up. Unbeknownst to you, it sends the detail of that crash down to Facebook. At Facebook, they got smart software that goes over the details of that crash to determine which part of the software crashed, and they align that with which parts of the software were changed recently, and they can, with pretty good accuracy of better than 95%, identify the developer who caused that crash. And if your software crashes from Facebook, within hours, that developer will get an email saying, the code changes you made probably caused this crash. Go fix it, okay? The developer is responsible for all this stuff, right? And so they create a lot of these automatic tools to do this type of stuff, okay? Another interesting example is HP. Now, HP is the worst possible company to work for because most people I know work for years writing software. It never sees the day of light. There's nothing more depressing than writing, for years on software, and nobody ever uses it. It's just thrown away. However, the firmware of their printers is very modern and it's agile. Every day the printers ship, it has new version of software of the most recent version that has been put out. So it changes continuously, so it's very agile on their firmware, which is sort of interesting. Anyway, so at Facebook, it's a little bit extreme. At Facebook, as a developer, no manager tells you what to do. You decide yourself. You define the product yourself. You can say, I got an idea for a new product. You just go develop it. You design it yourself. You go test it, write it yourself, implement it yourself. You test it yourself, you're responsible, and you go deploy it yourself. No adult supervision. So it's taking the traditional hierarchy that you have in companies and turns the whole concept on its head because the developers are in control. Okay? Now, there are such things as product managers. However, they're consultants. You as a developer can decide to do whatever you want. If you're smart, the product manager might know a thing or two. You go to the project manager or product manager and maybe ask some questions or give some ideas, etc. There's also tech management and how to do things, and there's an operational crowd that gives you advice, etc. You can consult with them. You don't have to, but you do everything. However, if you make a mistake, you will get an email and you will be woken up at 3 o'clock in the morning and you got to fix it. You're responsible for your own things, okay? And you have to fix them. It sometimes happens that new people come, and I've witnessed this twice already. Somebody relatively new with the company for less than 6 weeks, a junior developer puts out new code and it crashes the entire Facebook site. Okay, sounds terrible, but Facebook lives with that, just boots it all, gets it going again, and there's a no blame culture. Right? They try to find out what went wrong and try to address those concerns to make sure it doesn't happen again. Of course, if you crash the system 3 times in a row, some HR person will contact you and lead you out the door. But anyway, this thing here has turned out to be, for Facebook, really, really good. It's sort of similar to the open source model. If you look at Linux, nobody tells anybody to do what to do. You just develop code that you think is a good idea and you submit it. And if the people think it's a good idea, it'll get used and it'll be integrated in. So it's basically taking sort of the ideas to how open source software is developed and applying it within a company. It's actually quite revolutionary and it's quite model and it works very, very well. Productivity is an order of magnitude higher than most other software groups. And if we look at and you think, well, maybe productivity is high, but the quality is going down. I went in and measured the quality. The quality is getting better and better all the time. It's actually way better than industry standard, way better. You can Google the error. I've published all the errors that happen at Facebook, and you can go see those. Okay, so maybe to finish off, I firmly believe Agilist, I know is not a word, but companies that follow the Agile way are going to win, and everybody else is going to fall by the wayside and ultimately die of a dinosaur death. Okay? And it's relatively simple if you think about it. If you have an idea, the company that can get that idea out as product the fastest tends to win in a competitive environment. Let's say your competitor brings out a new product or has a new idea, a new feature. You say, that's fantastic. If you're agile, you can maybe within a few days, within a few weeks, emulate that feature or recreate it for your own product and bring it out relatively quickly. If you got the waterfall model, you got maybe a half a year delay, if not a year delay, to be able to do that. You got a bug fix, you fix it right away. If you got waterfall, it might take 3 months before you can fix that bug. You get fast feedback, and this has to do with the modern design of things. You put something out, you see how people use it. Does the click rate go up? If yes, if people are using it the way you expect it, you're great, continue on. If not, you can immediately go back and try something else. You can experiment with the users, and that's done all the time with modern software, right? The quality of the software goes way up, the risk goes way down, and the productivity goes up. So anybody who does Agile is going to win long term, and maybe that's why Facebook is beating Google right now in ad dollars. But anyway, that's sort of, here for a sign of how software, a video of how software is being developed. Anyway, so maybe I should open up for questions. Yes, ma'am.
You said that for the agile development, a lot of it is like, especially with a startup, is putting stuff out there and you, based on the response that you get, you adapt. How do these companies avoid a bad first impression so that like a bad name won't get out about a company, even if they do improve it?
Sure, I will repeat the question. So the danger, you get the software out quickly is the idea. And so the question is, well, if you get it out too quickly, you may leave a very bad impression. And once people have a bad impression, they will never come back to your software. So that is fair. You have to try that. Often you start out with an alpha group where you just got your family and friends who try it out first, and then you got beta users, right? So Facebook has that. So for example, for Android Facebook app, guess how many beta users they have? 3 million. So 3 million people test out. They sign up voluntarily, and they know they're going to get a product that's not ready, that fails far often, that has bugs and glitches. They know that. But just for the fun of it, they go and do it, and they report on errors. All they have to do is shake their cell phone, and automatically an error report's generated, and et cetera. So that's one way to do it, right? And you need a little bit of smarts. If you're, if you're totally untalented, you have no hope anyway, right? You can't measure your way through. Any other questions? Did that answer your question? Okay. Other questions? Yes, sir.
How does a company like Tesla that updates?
How do they update software?
How does it deal with insurance companies? Like, these are untested software, and they're getting updated every single day. What about security or something like that?
Okay, so I have a Tesla. It doesn't get updated every day, but it gets updated every. The version I get that I see is every couple weeks. Okay, but I think they update. They play with different people. I'm just not always the chosen one that they experiment with. Insurance companies love Tesla because number one, they have far fewer things that break. They're far secure company. Safety from a safety point of view, they're ranked number one. And even with their auto driving, self-driving, assist driving, or whatever you want to call it, they already have billions of miles logged, and they can show that they have fewer accidents if their control does the driving compared to humans. So it won't be perfect. They'll sometimes put in flaws, but they will also measure it, and they got ways to basically undo software changes that they made if they notice things are not working well. Like if they have a number, let's say they put out new object detection software, and they have a few near misses, they may quickly undo those updates to go back to the previous version while they find out what's actually going on. Make sense? You're not convinced. You had a question back there?
How do you, what would you recommend to prepare for an agile work, working in an agile?
That's a very good question. So what do you need to do to prepare to work in an agile environment? So the requirements are a little bit different. You see, you can be a terrible developer and work for a testing team, and you're just fine. You have a job for life at IBM or TD or Bank of Montreal or something like that. For Agile, you have to be more talented. You have to be a generalist because you've got to design stuff, you've got to test stuff, you've got to implement it, you've got to be an architect, you've got to maintain it. And unless your family's going to get very upset if you constantly get calls at 3 o'clock in the morning saying your software doesn't work. So you've got to be able to do that, right? So I would argue that typically the top quarter of a class here is suitable for Agile because you've got to have these generalistic environments. You don't have to be the best in everyone, but you get to have a nice rounded combination of being able to do everything. If you're very one-sided, then you're not very good. Then it'll be very, very difficult, right? So not everybody is suitable for Agile. And that doesn't talk negatively. So we had, for example, employees that are just not suited to a chaotic environment that Agile creates because they like structure. They like somebody who tells them what to do. So we sent them to IBM. And that was the best thing we did for both of us, right? Number one, we got rid of the employee, but that employee did very, very well at IBM because they're more suited for a structured type of environment where you got bosses and you got checks and you got balances, et cetera. So for some people, that doesn't speak negatively about the person. They're just more suited for that other type of environment. Okay. Any other questions?
I had a question.
Sure.
If someone's responsible for a chunk of software and they have all those responsibilities and they leave the company, how do you deal with replacing them?
That's a good question. So the question is, if somebody writes software and is responsible for it, but then they later leave the company, what happens? Somebody else may decide to jump in and take care of that software. Often case, that won't happen, and people just look at the stuff. It's whenever you look at anybody else's code, you sort of say, what the hell? This is junk. Throw it away. I'm going to rebuild it myself. Much better. And that's what usually happens. And so you get a lot of renewal of software, right? Because also you have other problems like at Facebook. There's a real problem. You sometimes, because everybody can do what they want, and there's some projects that are sexier than others, right? So you, for example, might have 3 or 4 groups that are working on new database technology that all does the same thing with the same goals, but they're completely, and only one of them is going to win. And so you could say that's a waste. But you tolerate that because you got the rule, you decide by yourself. Somebody goes to all these groups and say, are you aware that these other groups are doing it and that if you don't beat them, they will win and nobody's going to use their software? And they can all make their own decisions. They can go talk to these other groups, decide whether to amalgamate or not. Everything is left up to the developers, but it's not necessarily the most efficient way if you look at that. But if you look at the big picture and just look at the productivity numbers, they are far higher than they are in industry standards. Yes, sir.
How do you get paid in these companies? In a hierarchy, there is an objective measure of what you've done.
Yes.
But then here you say you're going to compete and you're going to lose. And
Sure. Okay, it's very simple. So, at a place like Facebook, you get a base salary. And, it's sort of high. I don't actually know what it is, but I think it's above $200,000 US, which makes it about 300,000 Canadian as a base salary, if you have a little bit of experience, right? And then you get bonuses, and bonuses can double the salary, right? So the way Facebook, let's say, incentivize their developers is you get your bonus depends to a large part on how many times does your code get executed, right? So if you write 2 lines, but those 2 lines are very important and they're in the core of the software that get executed thousands of times every second continuously, you get a big bonus, right? You can at the same time write 10,000 lines and if it only gets executed twice a year, you get no bonus, right? And so they measure your productivity by how many lines of code do you write that goes out to deployment, and then how often is that code actually used, actually executed, and they measure that all the time. Make sense?
So I think we're out of time. Let's thank.
Okay, thank you.